My name is Mitch Henderson, and today we're going to be talking about MSK with IAM authentication. MSK being Amazon Managed Streaming for Apache Kafka. IAM authentication is the authentication mechanisms that is most commonly used in AWS for access authorization and auditing. So what we're going to be talking about today is what is managed streaming for Apache Kafka or AWS MSK, and what is identity and access management or AWS IAM, how MSK works with IAM, why MSK and IAM are a great fit for each other, and why you would want to use them in maybe your project or some of the applications that you're building. And we'll walk a little bit through kind of how to set up an MSK cluster to use IAM authentication and configure some policies so that your applications can take advantage of the authentication mechanisms. So just to get us started, we're going to baseline on what managed streaming for Apache Kafka is. If you're familiar with Apache Kafka, it's a pub/sub messaging system at its base with an immutable log file as its core data structure. In more than that, though, it's really an ecosystem of components, from things like Debezium for CDC or connectors to connect data sources into and out of Kafka using Kafka Connect. So it's really an entire platform for messaging and interprocess communication or microservices with a large and rich ecosystem and integrations into the core Kafka or MSK brokers for data movement and streaming platforms. So what does MSK do for you as opposed to, running Apache Kafka on your own? One, it makes it far more accessible. We've done the heavy lifting of implementing best practices and design defaults and automating the deployment for you so that your application teams or yourself don't have to worry about, is my broker configured correctly? Am I choosing the right instances? All of those really nitty-gritty details that don't add any value to your business, we're taking care of for you. So it really allows you to focus on what your core business value prop is, as opposed to worrying about Apache Kafka. In addition to that, AWS is committed to improving open source Apache Kafka so that there's a rich ecosystem built around it for the foreseeable future, right? So that we can, in the future, you can rely that or know that Kafka is going to be around and the community is going to continue to drive forward. In addition to that, because MSK is an AWS service, we've obviously built in integrations with other AWS services that you can take advantage of in your application. Things like Glue Schema Registry, which allows you to have standardized schemas stored in AWS Glue that you can share amongst your applications so that they can all talk and understand the data structures inside of each message. This also allows for schema evolution. So as your applications change and grow, you can predictably evolve those schemas so that they can have backwards and forwards compatibility. And then what Jeremy's going to talk about in just a minute is an integration with Kinesis data analytics for Flink. This allows for really complex, really rich stream processing in conjunction with MSK so that you can modify, enrich, or filter out events as they come in to your MSK system for use in other systems. Say you want to have a data pipeline that is ingested in MSK, goes through Apache Flink, and then lands in Redshift or RDS. Flink can allow you to do that. And of course, we integrate tightly with Amazon's data migration service so that if you want to pull data out of your databases and push that data in a real-time or near real-time fashion into MSK, we can help you out with that too. And the ever popular AWS Lambda also has a native trigger that works with MSK so that as messages flow into MSK, you can trigger your Lambda functions to do whatever processing that you want or have built already off of your MSK topics. And then for security and SSL sharing or even authentication, we can also do or store your SSL certificates in AWS Certificate Manager. And this allows us to also have one of our other authentication options, which is mutual TLS, have all of those certificates stored inside of AWS for ease of maintenance. And of course, the topic of today's talk, we also integrate natively with IAM authentication now for things like cluster APIs, so building clusters, destroying clusters, changing clusters. In addition to that, we have fine-grained access control on the topics and permissioning of users and roles inside of MSK. And of course, because it is AWS and security is job zero here, we also have KMS storage on all of the data volumes so that they're securely encrypted at rest. As well as for ease of deployment, MSK natively integrates with CloudFormation for provisioning and maintenance. And of course, CloudWatch for all the metrics and logging out of your MSK clusters. Because Apache Kafka has been around a long time, and we see this use case a lot, we also have some really detailed guides for a lift and shift migration or a migration to MSK from your existing, say, on-prem or even cloud-hosted Apache Kafka clusters. And the link's in the slide here, but it's a really standardized way to get data or synchronize data between two Kafka deployments. And you can utilize your MSK deployment in your VPC for this. So as a little bit of background as to kind of why we introduced IAM, your existing authentication mechanisms inside of MSK today are plain text, which is essentially no authentication. This is only suggested for dev use and should not be used in a production environment because it also offers essentially zero security. We also offer SASL Scram, which is a username and password combo with the username and password securely stored in the AWS Secrets Manager. Now, the problem with this one is that you have to then distribute those credentials to your clients. And oftentimes that includes storing them in plain text with the clients. So this is an acceptable form of authentication unless storing them alongside your clients is kind of a non-starter for many people. The third option that we have is mutual TLS. And that's where the brokers, the MSK brokers, and the clients each have their own SSL certificates that they can exchange to prove they are who they are, right? So I have, my application is called Application 1. I have an SSL certificate that has Application 1 as its principal, and that proves my identity to the Kafka brokers. The pro of this one is it's a highly secure mechanism. The downfall is you have to manage all those SSL certificates, key stores, and trust stores on your own. So you have to create the keys or the SSL certificates and securely distribute them to each one of your clients. So if you're doing any sort of inter-account or third-party account authentication, this can be a little bit troublesome. Now, IAM authentication is the fourth authentication mechanism that we've recently introduced, and it's a standard inside of AWS. It's a library that you can import into your clients, and you provide an API key as well as a secret, and that proves who you are. And all of your IAM roles and users are stored in the IAM database that you can distribute and utilize for interacting with, say, another account inside of AWS or even from external parties in AWS, as long as they have the credentials, the API key, as well as secret. So what does identity and access management, or IAM, really offer? It's the 3 A's. It's your authentication, authorization, and auditing. It validates who you are against a centralized credential store. And then you can use the same mechanisms for managing your fine-grained policies for what you're authorized to. Say if I'm authorized to a Redshift cluster to do reads and an MSK cluster to do writes. All of those policies are stored in your IAM console. And of course, it also allows you to audit which users or which roles have access to which services and what they can do inside of those services and what they have done inside those services. So if we break this down a little bit deeper, we authenticate to IAM with our username and password, which is actually an API key and secret. Or we can also add a secondary layer of security here with a multi-factor authentication, say a token, to be able to have a second layer of authentication. As well as we can federate this out to third parties also, so that if we authenticate through a third party, we can then authenticate into the IAM ecosystem. And then we authorize users that inside of with IAM policies. And these define what the users can do or cannot do inside of the AWS service that is utilized. And we can audit this interactions and the history of what each user has access to or had access to via AWS CloudTrail. So if we combine the two, IAM with MSK, this is kind of the things that we really get out of it, right? In all of the other authentication options, it's not really all that secure by default. With IAM, everything is absolutely secure by default. The users aren't allowed to do anything unless you permission them to do that. So it gives us a really secure base layer to work from for least privilege access. It also gives us the ability to centralize the management of all of our IAM credentials and policies. We don't have to know that or go to each individual MSK cluster to pull out each policy and each ACL that a user would is permissioned for. We can go to one console or one API and pull out everything that that user is authorized to access, as well as what they're authorized to do on that with that cluster. So it gives us a really good place to audit all of the things that a user can do with their IAM credentials. And then we talked a little bit about federation. If you're already using a third-party credentials provider, we can tie directly into IAM with use for those. The folks like OneLogin or Okta or Auth0 or Ping or IBM or RSA, we can tie directly into those credential providers to bring those policies and those users and those roles into the IAM authentication system for use in the wider AWS ecosystem. And then for a lot of folks and a lot of organizations, they divvy up their AWS access with different accounts per application or per application team or per line of business. So they have a lot of cross-account connectivity going on. So the secure account connectivity really allows us to have one account manage their IAM principles and their IAM roles, and then the second account can utilize those same accounts, the same principles, and manage the policies associated with those accounts for authentication into their MSK cluster or their resources inside of their VPC. This gives us a really secure way to authorize and authenticate external parties into your MSK cluster. So how would we go about setting this up? The setup is pretty simple. If you're familiar with Kafka clients, you've always kind of provided these same things. The one change here is that we do have a third-party library that is open source that you can go and take a look at on GitHub or Maven Central that you'll need to import into your clients. It's the AWS MSK IAM authentication library. So I provided an example POM entry here for your dependency. And you'll just simply import that into your Maven build or Gradle build. And then for your producers, and the same configurations apply to clients, but I've shown producer examples here, you'll change your SASL mechanism to be the AWS MSK IAM, change your SASL Jazz config to use the IAM login module, and your SASL client callback handler class to use the IAM callback handler class so it knows how to handle errors or successes in a proper way. And that's really the only conversions or changes from your standard Kafka clients that you'll need to make. And these same configurations work with the wider ecosystem. So if you're using, say, Kafka Connect or Kafka Streams, these same configurations work there. You may have to change which properties that you're feeding your clients, but these are the generalized properties to make that work. Then you'll need to go into the AWS MSK console or you can do this via CloudFormation or CDK, but you'll need to custom create an MSK cluster and tell it that you want to use IAM for access controls. From there, you'll go into your IAM console and create a policy. Now, we're providing the Apache Kafka APIs for MSK as the service that you will use for this policy. And that allows you to pick from a list of APIs and access controls that you want to apply to this policy. In this example, I've just given this particular policy access to all of my Kafka APIs as a super user. But as you can see, there's also list, read, and write capabilities that you can filter down into. If you're already familiar with the Kafka ACLs commands and which APIs and policies you can apply there, we have an equivalent of almost all of those inside of the Apache Kafka APIs for MSK. So there should be a pretty direct translation to what you would provide as an IAM policy here. From there, you go in and you can select the cluster, the group, the topic, as well as the transactional ID for exactly one semantics that you want to apply this policy to. So if I want to create a policy for read and write access to topic A, I can create a policy for that. And then what you would fill in there is where the cluster is located, my account that it's owned by, the cluster name, the cluster UID, and the topic name that the policy is for. Then I would attach that, or this is a summary of what that policy would look like after it's created. In this case, I've created a read policy for my MSK test topic 1. And then I can apply that to my users by just simply clicking the add permissions button inside of that user for inside of IAM, or that role inside of IAM. So that ends what I was going to speak of today, but here's some links that can help get you started with using IAM with MSK. We have a really great blog that kind of goes into some of the example policies, some of the initial setup of IAM with MSK, as well as a more in-depth documentation for using IAM with MSK. And of course, our lab site that has not only IAM, a lab, but a number of other labs to help you get started using MSK. And now off to Jeremy to talk about Kinesis Data Analytics Studio.
Thanks, Mitch, and thanks for the overview of MSK with IAM authentication. And I think it's a natural transition to what you would likely want to do with data once you have it flowing into an MSK cluster from for authenticating with IAM. It's a natural transition to want to start processing that data, to start understanding what type of data you're working with, and ultimately analyzing it. So for that, what I wanted to showcase and give a demo of today was a feature that was just released within Kinesis Data Analytics called Kinesis Data Analytics Studio. So the easiest way to get started with Kinesis Data Analytics Studio with MSK is actually if you come over to the MSK tab. And I've already pre-created a cluster called My MSK Cluster. And if you just look at the top right of the screen, we can say Process Data in Real Time. And simply by clicking this button that says Apache Flink Studio Notebook, it's going to bring you to a Create wizard that will be pre-configured with the correct IAM policies and the correct VPC that your MSK cluster is running in. So this is a really easy way to not only set up your MSK cluster with IAM permissions or any other type of authentication that you would need, but also with a few clicks of a button, start processing that data and start understanding what data is flowing through. So on this Create Studio Notebook page, we can do things like give the notebook a name. We would pick an AWS Glue database to reference And that's really for whenever we create an in-memory table for our Kinesis Data Analytics Studio to process data upon. It's actually going to create a subsequent table in the Glue data catalog so that other applications can reference that table when they do their own processing. And we'll see what that looks like a little bit later. We're going to keep these as default, and just because this takes a little bit of time, I've already pre-created this notebook, and our notebook is called Kafka Demo. And I'll just scroll down here for just a second. We can see that it's running Apache Flink 1.11, as well as Apache Zeppelin 0.9. And if I didn't say this before, what Kinesis Data Analytics Studio essentially is an interactive notebook experience for Apache Flink. And what this means is that it's very easy to get up and started running SQL, Scala, or Python applications in Apache Flink and see the results of your queries in real time in a notebook. So we'll take a look at that. But before we get into the notebook, I did want to mention that you can also control how your notebook scales. So this notebook is no different from running a traditional Kinesis Data Analytics application, where you can specify the number of KPUs or Kinesis processing units that you want to use to process your data. And there's nothing preventing you from running a fully fledged production Apache Flink workload in a notebook. We set up our logging and monitoring, and down here you can see that our notebook was already pre-configured to the VPC that I had set up with Amazon MSK. And just at the bottom here, we can also see that we can, if we should choose, we can deploy this application as a fully fledged headless Kinesis Data Analytics application. And the reason you might want to do that is because these notebooks don't provide the resiliency and the safe way to run an Apache Flink application in production by providing things like checkpoints and snapshots. So those are not going to be configured by default in the notebook, because these are meant to be, the notebook is meant to be more or less a testing framework, but eventually we want to be able to scale these notebooks so that you can run them fully fledged in production. And we have some other options here that we won't go into. So let's go ahead and open in Apache Zeppelin. So once this opens up, you'll see, I've already written some code here, but you will see some sample queries here that you can start interacting with your data streams upon. So the first paragraph that I want to draw your attention to is this one that I have the header called create. So this is really where Kinesis Data Analytics Studio is interacting with our MSK or Kafka cluster. So you can see I have a create statement. I'm creating a table called my table with 3 fields: a ticker, a price, and an event time. Now that event time is going to have an associated watermark, and in the Apache Flink terms, what that essentially does is it allows for your event time processing engine with Apache Flink to allow for lateness or late arriving records as far as 5 seconds late. And the reason that's important is because we can have late arriving records for network latency or any sort of other hiccups along the way. And we want to be able to process that data as realistically as possible. So we use event time to most accurately reflect when the events actually happened as we're processing them. And below that, you'll see I'm specifying the connector called Kafka. I've created a topic called stock topic, and then I'm specifying those Bootstrap servers or Bootstrap brokers to be used within Kinesis Data Analytics Studio. I'm going to read from the earliest offset, and we're expecting JSON. So before we start sending data, I just want to go over to the Glue console so you can see what that data looks like in Glue, in the Glue data catalog. So I created my table. It's right here. And we can see that, that I've already got the bootstrap brokers and all of the other metadata about the table successfully replicated in AWS Glue. And I've already run this previously just so that the demo is a little bit faster, but your first paragraph as you run it will always take a little bit longer just because it has to spin up the resources to run the notebook. But now that we've got this configured, let's go ahead and send some data into our MSK cluster. And I've got this script we can see on an EC2 instance that's in the same VPC as our MSK cluster. All this is doing is sending random stock ticker information for some various stock companies. And we're going to send some random prices along with the current time. So let's go ahead and run this. Python 3 stock.py. And we have some data being sent to Kafka. And right away, we can go ahead and execute this second paragraph, which is called query. And within a few seconds, we should see some results come back from the table. You can see on the top right, we have Flink job running, and we have some results coming back. Now, I have limited this result set to 10, just so that it's a little bit more interesting when we look at the visualizations. But you can see that within a few minutes, we're already able to receive data coming back from MSK. Now let's go over to visualize this data in different ways. We can see this data in a bar chart format or a pie chart. And this is really helpful for understanding what's going on in your data as you're sending it to Kafka. And it's a great way to debug your Apache Flink applications. So I'm going to stop this paragraph just so we can continue on and look at a couple other interesting ways we can interact with the data. We can, of course, filter the result set. Maybe I'm just interested in data coming from Amazon. So I've filtered the data coming in from my table where the ticker symbol is AM and then a wildcard. So here we're only getting data from the Amazon stock ticker, and that's an easy way to filter out your Kafka topic to do some deeper analysis on a specific data type. And let's go on to the next one. So we can also create, let me just make sure I stop that. We can also create what are called UDFs, or user-defined functions. These are actually Scala classes or Scala functions that we can use and leverage to operate on each record as it comes in through our Kafka topic. So I defined two UDFs here. One of them converts a datetime object as our event time into epoch seconds, or time represented in milliseconds. The next UDF converts any incoming string into that UDF into lowercase. And both those UDFs are going to be registered with our streaming table environment so that we can use it within either Python or Scala or SQL. So let's do just that. We've just registered those two functions, datetime to epoch and to lower. So I'm going to go ahead and use those UDFs on our incoming data. And you can see that we have a new schema here, lowercase ticker as well as epoch time. And you can see that our ticker has been successfully converted to lowercase, and our timestamp has been converted to milliseconds. So this is really powerful, and of course it's a simple example, but you can see how you could do things relatively simply to quite complicated transformations of your data using user-defined functions. Let's stop that. We can also get enrichment from external data sources. So that would be, let's say you have a reference table in something like Amazon S3. I just have this reference table that contains the company details that we are working with in these stock tickers. And then we can actually join that with our existing data stream coming from Kafka to get more information about the stock as it comes in. So let's see what that looks like. You can see we have the company name, the company city, and the company state abbreviation. And let's see when this comes back. So while we wait, let's just go ahead and go into the Flink web UI and see that we can actually visualize the Flink DAG, or directed acyclic graph, of the data that's coming in and how we're able to process it. So this is even more useful for the way you can debug your application. We can go into each of these subtasks and see how the data is being processed, and how our data is performing within the notebook. And we still don't have any data back. Not sure why. So let's go ahead and carry on, and we'll come back to that if there's time. Just make sure my data is still being sent. Yes. And then, of course, we can also do things like tumbling windows. We can run a tumbling window on our data set to calculate things like a group aggregate or a count. And so for each window of time, each 10 seconds, we can see the count for all of our stock tickers. And we can, of course, plot that as well in any of the other visualizations that we'd want to. And then I won't go into this, but we do have a sliding window. The main difference between a tumbling window and a sliding window, the tumbling windows are going to be non-overlapping. So they would be 10 seconds here, then 10 seconds, then 10 seconds. And a sliding window would be starting at time 0, then starting at time 1, and time 2. Each of those would be its own window, and those would have overlap. So those are just two different ways to process your data in an aggregate way. But then the last example that I want to showcase which is really powerful, is this query pattern called match recognize. So what this allows you to do is take in data from your Kafka topic and identify interesting patterns out of that data. And the match recognize clause is very powerful. It allows you to define specific patterns in your data so that you're only seeing that anomalous pattern, or only seeing that specific way that the data looks, and that's only going to be your result back. So in this particular example, what I'm looking for is a drop in price of our stock ticker information of $50 within 10 minutes. And maybe that would be indicative of a sell-off or some fraud or something like that. And you could see how you could use match recognize to identify anomalous or interesting details within your Kafka topic or your stream of data. So if we go ahead and run this, oops, there we go. Within a few seconds, we should be able to see some interesting anomalous data come off of our Kafka topic. So we can see for our one ticker, we had a drop off or a change in price of $51. The initial price was $85 and the last price was $21. And that happened over the course of 1 millisecond. And you can, of course, see how this could be extrapolated out to detect things like fraud or any anomalous data. And so there, within the course of a few minutes, I'm able to get some really powerful insights out of data that's flowing into our Kafka topic, into our Kafka cluster. And we could go ahead and use this to influence business decisions and influence how we think about data flowing into our Kafka topics. Now, the thing that I'm not going to show in this demo is something that you could also do, which is very powerful, which is called syncing the data. We could take any of these results from the queries and sync them to another Kafka topic to do some later processing. Mitch was talking about microservices. We could use this notebook as its own microservice. We could also sync this data to something like Amazon S3 to do even more analysis on a batch scale. And that's just a really powerful way that we could, in a few minutes, writing some simple SQL statements, get some really powerful insights out of our data. And so that's Kinesis Data Analytics Studio working with managed streaming for Kafka. And we really look forward to seeing how customers leverage both these technologies to help their business process data in real time. Mitch, anything else to add?
No, Jeremy, that was great. Good information around building and deploying KDA Studio apps.
Thank you. And I'm sure we'll be hanging around to answer any questions that you might have in the chat. So stick around, or you can always reach out to myself or Mitch. So thanks for tuning in.